Hello, good morning guys. Okay, ang i-discuss natin ngayon ay yung tinatawag nating FET Frequency Response. So, ang focus ko lang dito ay isang circuit lang for okay? So, kapag low frequency ang nakakaapekto sa ating low frequency response ay yung ating coupling capacitor CG at CC o pwede mo siyang tawagin na CD at ang ating bypass capacitor na CS. So these are the formulas that we will use as we go along the discussion. So this is for the FLG, this is for the FLC. By the way, this R is the AC drain resistance. Kasi pag BJT, ang concern natin ay si R prime E, yan ay yung AC emitter resistance. Dito sa mga FET, ang meron tayo ay si RD, yun si AC drain resistance. Okay? And then this is the formula that we will use for the frequency, which is due to the bypass capacitor CS, this one. So, okay. So, pagka-compute natin ang values ng FLG, FLS, at FLC or FLD, ang pipiliin natin sa kanila ay yung pinaka-mataas at yung i-consider natin na FCL DOM or Dominant Low Cutoff Frequency. Kasi bawat frequency na yan, FLG, FLS, FLC, yan, nagdudulot ng certain roll-off or yung pagbaba. So, ang pipiliin natin is yung pinakamataas again. Okay? On this diagram, ang meron dyan ay FLS. So, hindi naman laging FLS yung pinakamataas. So, this is for just visualization. Okay, next, we move on to the high frequency response. Okay, pag high frequency response naman, ang nakaka-affect doon sa ating response ay yung ating internal capacitances. There are two types of internal capacitances. You have the junction capacitance or the inter-electrode capacitance and the wiring capacitances. Okay, so these are the inter-electrode or the junction capacitances. And this is the input wiring capacitance and this is the output wiring capacitance. So, yung mga values na yan, yung mga capacitors na yan, ang gusto kasi natin, open yan. Kaya lang, at low frequency, at high frequency, nagiging effective short. Let us see what will be the effect of those frequencies. And kung napansin, input at output yung pag-uusapan natin kapag high. Kasi dalawa lang yung gagamitin nating formula. This one is for the input network or FHI, high frequency cutoff. As you can see, you have here the RTHI. Okay, so this is the formula. And you have the CI or the input capacitance. That is just the sum of the input wiring capacitance. The CGS, kasi ito yun, nasa input side. And the CMI. This CMI is the Miller effect capacitance. Okay? So, may nadadagdag kang certain value ng capacitance and it is determined by this formula. Okay? Next is for the output network high frequency cutoff. Still, you have the RTHO. Okay? You just have to remember that if RT is equal to infinity ohms, RTHO is just equal to the parallel combination of your drain resistance and your load resistance. Next is for the CO or the output capacitance. That is just the sum of the output wiring capacitance. The CDS, output side na po kasi tayo. And the CMO. Okay, the effective Miller capacitance is determined by this factor 1 minus 1 over AB over A times CGD. And as you can see, may factor tayong AB. So when starting to solve or analyzing the high frequency response, of FET, you first have to compute for the value of your voltage gain. Okay? So, here my sample problem and let us start solving. So first, let us compute the low cutoff frequencies and let us determine the dominant low cutoff frequency. Okay, so these are the values. You have 10 kilo ohms here, signal, signal resistance. You have here CG of 0.01 and so on. At the same time, hindi mo masasolve ang ang isang FET kapag walang binigay na IDSS at yung value ng ating VGS of. This circuit is from Boylestad. So in Boylestad, E equal to VGS of. Okay? Pero kapag kay Floyd, hindi po yan magka-equal. Okay? How do we start? First, we have to perform the DC analysis. Okay? So, KVL muna ako dito in order to find VGS. Okay? Ako yun, negative VGS minus 1,000 ID equal to 0. Okay? So, kung babalikan nyo ang ating DC analysis, this is just ID and IG here is just 0 amperes kaya hindi sinama sa pag-KVL. So, it is very clear that is equal to negative 1,000 ID. And then, since I have VGS, I can now utilize the Shockley's equation, and that is ID is equal to IDSS 1 minus VGS all over VGS of squared. So, is the unknown. VGS is 8 milliamperes. 1 minus the value of VGS is negative 1,000 ID all over VGS of which is 4 squared. Okay, you may be wondering, Sir, Engineer Benong, ang VP is negative 4. VP is equal to negative VGS of. Again, this is for Floyd. Kapag ganyan yung nakita mong circuit, may kulay asul, yan ay galing sa Boylestad. At kay Boylestad, again, VP is equal to VGS. Okay, so don't get. Okay, so we will utilize our calculators to solve this one. So let's say ID is equal to X, so we have X is equal to 8 milli, 1 minus negative 1,000 X over negative 4 squared. So kung pro ka na, hindi mo na kailangan pa na X. Okay, so X is equal to 8 milliamperes, 1 minus negative 1 alpha negative 4 squared. So, kung i-review niyo yung videos ko about a simple calculator for JFET, solving circuits for JFET, solve natin yung value ng x1 at x2 kasi quadratic yung equation natin, so may dalawa tayong value ng x. Calc, I set the value of x first to positive 9. Ano natin ay 8 milliamperes. Okay? Shift calc, iset ko naman yung value kanina. At ang nakukuha naman natin ay 2 milliamperes. By the rule, you should choose the value which is the lowest. So from here, ID is equal to milliamperes. And store ko siya sa D. Okay, pag nag-store ka sa calculator, isulat mo sa solution para hindi ka nalilito. Okay. Now that we have the value of our ID, now we can compute for the value of our GM. So GM is equal to GMO 1 minus VGS over VGS. So another derived formula, if we're gonna set GMO is equal to 2 over the absolute value of VP. GM could also be calculated using 2 IDSS all over the absolute value of VP times the square root of ID all over IDSS. Okay, guys. So what is GM? What is GMO? GM is your transconductance, while GMO is your maximum transfer conductance or transconductance. Okay? So, yung formula na yan ay na-derive lang gamit ang Shockley's equation. So, GM is equal to 2 times 8 milli all over the absolute value of -4 times the square root of I, which is 2 milliamperes all over IDSS, which is 8 milliamperes. And from that, I could compute that value of my GM. So 2 times 8 times -3 all over the absolute value of -4 times, since parehas lang naman yung milli, pwedeng ang gawin ko, square root of 2 over 8 na lang, or 2 divided by 8. So that is, ko na sa D. So bakit sa D ulit? Kasi una, yung drain current ko. Ginamit ko lang yung drain current ko para makompute ang value ng aking transconductance. So that is 2 millisieverts. Okay? Since we have GM, unahin na muna natin computed yung value ng ating FL o FLS o yung ating cutoff frequency na dulot bypass capacitor CS. So FLS is equal to 1 over 2 pi REQ times CS. Okay? From this, you should remember or recall that the formula for the equivalent resistance here is equal to RS all over 1 plus times 1 plus GM times the drain resistance. That, kinumpute natin po yung value ng GM all over RD plus the combination of your drain resistance and your load resistance. We should take note that if RD or the resistance is approximately or equal to infinity ohms, or it is a very amount of resistance, your equivalent resistance will just be equal to RS parallel with 1 over GM. Okay? So, in our case, the value of our is or RD is infinity ohms. So, it is very clear that we will use the value of this formula. Okay? So, REQ is equal to RS parallel with 1 over GM. So, our RS is 1 kilo ohms parallel with 1 over GM. In-store natin sa variable D kanina. Okay, so that's 1 times plus alpha D. Diba 1 over D, alpha D inverse. Eh kaya, inverse lang natin ulit. So that's just plus D. So, 1 inverse. So, we have 333.33. Oh, ko yan kay. So, that's 333.33 store to high. Okay. Computing the value of FLS, it is equal to 1 over 2 pi times R, which is at constant A, times CS, which is equal to 2 microfarad. So our FLS, is 1 over 2 pi times A times 2 micro. And that is 238.7324 hertz. Okay. Next, we could start computing the value of your FLG, and that is equal to 1 over 2 pi times the sum of your R signal plus Zi times Cg. In our case, on our circuit, okay, here, your Zi is just equal to the value of your Rg. Okay, kasi ito lang yung nasa input side. Kung sakaling yan ay naging voltage divider bias, ang Zi mo ay equal sa R upper, R lower. Sa combination ng R upper at R lower. Pero in our case, kapag ganyan yung circuit, your Zi is just equal to Rg. In our case nga, that is equal to 1 mega ohms. Okay? So, direct ako na to. This is equal to okay, so 2 pi times R sig, which is 10K, Zi, which is 1 mega, times Cg, which is 0.01 microfarad. So let us see. 2 pi times 10 times 3 plus 1 times 6 times 0.01 microfarad. That is equal 15.7579. Okay. Next, we compute the value of your cutoff frequency due to your coupling capacitor at the output side. So that is FLC or FLD. So that is equal to 1 over 2 pi times RL plus ZO times CC, or this is the CT. Okay, on our case, your ZO is equal to the parallel combination of your drain resistance and AC drain resistance. Again, kapag ang AC drain resistance ay equal sa infinity ohms, we just ignore it, and so your ZO will just be equal to RD. In our case, your RD or AC drain resistance, is equal to infinity ohms. So our ZO here is equal to 4.7 kilo ohms. Okay, so FLC is equal to 1 over 2 pi times RL, which is equal to 2.2 kilo ohms, plus RD na 4.7 kilo ohms, times CC, which is equal to 0.05 microfarad. So FLC or FLD is equal to 461.3189. 461.3189 hertz. Okay. So let us observe the values of your FLC 461, your FLG 15.7579, and your FLS, which is equal to 238.74. Okay, it is very obvious that FLC is the highest among the three values of your low cutoff frequency. So we consider this as the dominant low cutoff frequency, or the FCL dot. So that is how you're going to analyze a FET circuit at its low response. So now let us analyze this FET circuit on frequency response. Okay, so for high frequency response, since kung nare-remember nyo yung formula for the input and output capacitances, meron dong isang ina-add tayo, the Miller capacitance. the CMI and the CM. So the common thing about those capacitances, ginagamitan siya ng factor E or your voltage gain. The first step for solving or analyzing certain FET for high frequency response is to compute for voltage gain. Okay, and by the way, you cannot solve or analyze high frequency response without your internal capacitances. The junction capacitance and the wiring capacitance. Okay, so for this FET, the value of AV is equal to GM times RD times the combination of your drain resistance and load resistance. Okay, you could remember your GM is at is a variable in your calculator. The value of your ID is equal to 4.7 ohms, and the value of your RL is 2.2 kilo ohms. Okay, so AV, so that's negative T times 4.7 times 3 inverse plus 2 times 3 inverse. Parenthesis ulit tapos inverse. Okay, so the value of your AV here is 0.997. Okay, so the thing that you should recall, baka sabihin mo ay ang baba naman. Do not forget, FET po ito. At ang isang ng FET ay mas mababa ang gain niya sa BJT. Kasi ang BJT pwedeng umabot yung kanyang gain ng mga 100, 200, pero ang isang FET hindi aabot ng ganong kalaki ang gain. So, store ko na siya kay A. Negative 2.9971. Store. As you can see, kapag nag-store ako, isinusulat ko siya at binibilugan ko para hindi ako nalilito. Okay. So, the first thing that we should compute is the input network frequency cutoff. Okay, so that's the FHI and equal to 1 over 2 pi RTHI CI. Okay, so the value of your RTHI is just the parallel combination of your signal resistance and gate resistance. So this one and this one will just be in parallel. So RTHI is equal to 10K parallel with 1 mega. So let's see how much is that. 10 times inverse plus 1 times 6 hands inverse. That is equal to 9.9 kilo ohms. So store ko siya kay B. And then, to compute for the value of capacitance, you have the input wiring capacitance plus CGD. Diba nandito yung CGD? Okay? Plus your CMI or the input Miller capacitance. On our case, CMI 1 minus AV times C times sorry, this is CGS. Ito pala ang CGD. Times C. Yan. Okay. So, your input wiring capacitance is equal to 5 picofarad plus CGS, which is equal to 4 picofarad plus CMI, so that is 1 minus AV. Ang AV natin constant A times the value of CGD, which is equal to 2 picofarad, and CI, right? So that's 5 negative. I'm gonna store yung value ko. Store ko siya kay B. Okay, so that's times negative 12 plus 4 times negative 12 plus 1 minus A, 2 times negative 12. So, that is equal to 16.9 picofarad. Store ko siya kay C. So, CI is equal to 16.99 picofarad. Nakastore po siya kay C. Okay, now, we could start computing the value of your input network high frequency cutoff. So, F is equal to 1 over 2 pi RTHI na nakay variable B times CI na nakay C. So, FHI is equal to 2 pi times B times C. And inverse, it is equal to 945.89. 945.892 kilohertz. Kasi naka times 10 raised to 3 po siya. So that's the value of your FHI. Now, for the value of FHO, that is equal to 1 over 2 pi RTHO times CO. RTHO is equal to the parallel combination of your drain resistance RD and your load resistance RL. So that is equal to 4.7K para 2.2K. So RTHO 4.7 times 3 ipaparallel kay 2.2K equal to 1.50 kilo ohms. Store ko siya. Okay. Next, for the value of CO. So, ang CO, sino bang capacitance na nandito sa output side? Si C, CDS. Okay? And tsaka si CWO or si output wiring capacitance. So, si output wiring capacitance plus CDS plus your CO. Or simply, CMO is equal to 1 minus 1 over AV times CGD. So, your CWO is equal to 6 picofarad, while your C is equal to 0.5 picofarad. So, this is equal to 6 picofarad plus 0.5 picofarad plus 1 minus 1 over AV na nasa variable A times CGT, which is equal to 2 picofarad, and your CO is equal to 2 times negative 12 is equal to 9.17 picofarad. Okay? Store ko siya kay F. So, FHI or FHO is equal to 1 over 2 pi RTHO na constant na kay variable E times CO na kay variable F. So, FHO is equal to 2 pi times E F. So, equal to 11.5853 megahertz. Okay. And if we're going to compare the values for FHI and FHO, it is very clear na mas mababa si FHI. So, we will consider as the dominant high cutoff frequency. Okay? So, siya yung predominant value doon sa ating bode plot. So, those are the ways and the techniques on how are you gonna analyze FET amplifier during low frequency response, high frequency response. So that's all. Thank you.